Hi kids, we will be going with this unit 6 discussion. You can look at the first question. A point object is moving at 4 cm per second in the direction parallel to the principal axis. Object is at a distance 2 above the axis of the concave mirror of focal length. Find the speed of the image when the object is 15 cm away. So the first thing is, we'll be seeing if an object is here where the image will be getting formed. Object distance is minus 15, focal length is minus 10, so image distance is minus 30. So the meaning is image will be forming somewhere here. For this point, image will be forming here, but we'll be taking an imaginary arrow here. So we'll be finding where is its image. Magnification is going to be minus 2. The meaning is it will be inverted and which will be at a distance 4 cm. Now if you move this, then the image is going to move and change its size also. I mean the imaginary arrow size, that we know. Now if you move this by small amount, if this changes by small amount, this one also changes by small amount. How to find that? That is going to be given by differentiation, and they said du by dt is 4. I am taking that is positive x-axis, or you can go sign convention also. Anyway, I am getting image speed is going to be minus 16. The meaning is it is going this way with 16 units. If this thing is moved this way with 4 units, this will be moving this way with 16 units. But apart from that, it will be increasing its size also. So image is moving this way also. How to understand that? For that, if you differentiate magnification, both are changing. You will be getting the values, and v dash we already found. We can substitute v value, u value we already found. You can substitute. Then you will be getting minus 8 by 5. The meaning is it is increasing at a rate 8 by 5, or at least the speed is going to be 8 by 5 in y-axis. Sorry, we found only m dash, right? Okay, we can substitute it back here. So if you want to find the velocity, basically you need to find at what rate height of the image is increasing. But luckily in this case, height of the object, that imaginary arrow is fixed, so its differentiation is going to be 0. And if this differentiation we already found, when you plug in the value, you are getting it as minus 16 by 5. Minus 16 by 5, right? So then we understood its horizontal velocity is this much, vertical velocity is this much, resultant is going to be root of this square plus this square. A man looks down on a fish of length 5 cm. His eye is 2 meter above the surface of the water. Fish is 2 meter below. Understand this length is very small when compared to this length. This angle is going to be small. So if there is no water, then the angle subtended will be, this is 5 cm and this length is very big, so this angles will be small. So if this length is L theta is going to be 5. 4 theta is going to be 5 cm. Now when you pour liquid, now I have drawn an exaggerated figure, but you understand angles are small. Now the rays which are coming from here, they will be getting refracted and they will be reaching the eye, or you can see like which ray out of all the rays which are coming from here, which ray is going to reach the eye. So we have drawn some rough figure. So angle subtended is going to be this angle, which is 2y. As the angles are small, I can go with refraction in Snell's law. Mu sin r equals to mu sin I, 1 sin I. So sin r and sin I, they will be equal to r and I respectively. So you will be getting the relation. And if this angle is r, this angle is I. So this angle is going to be I. If this is I, this is going to be I by symmetry, the same thing. So, and these angles were small. So this length is 2. So if this length is 2, this length is going to be 2 times of I. If this length is 2, this length is going to be 2 times of r. So total length is 4 times of I plus 4 times of r, which is equals to 5 into 10 power minus 2 given. And the relation between r and I is also known. When you substitute it back, you will get 7i, but we need 2i. 2i is the angle subtended now. Theta 1 is the angle subtended before. Then you should take the ratio of 2y to theta 1. They were asking incorrect. Cutoff wavelength of X-rays is independent of filament voltage. Filament is something what you will be heating, and number of electrons coming out depends on filament voltage. Cutoff wavelength depends on the potential difference you will be applying across the anode and cathode thing. So independent is, that's correct. Presence of K alpha in X-ray spectrum means L series. K alpha in the sense there is a vacancy created in K shell which is being occupied from the electron which was present from the L shell. Because of this, there will be vacancy coming here which will be occupied by some other thing. So there will be L series will be present. Increase in filament current increases the intensity of the X-ray. Increasing the filament current increases the number of electrons coming out. Once you accelerate them, the number of electrons increases, intensity of the X-ray depends on the number of electrons sitting, obviously. So that's also correct. Presence of L series. Now this doesn't need to be. Now K shell, if this was occupied with electron and this was occupied with electron, if some electron is coming with some energy which is not sufficient to knock this out but can knock this out, and that can go out and which will be replaced by some other thing. So L series can be present, but that doesn't mean K series will be present in that case. So this is wrong, but we need to mark incorrect. So option D is the one we should be marking. Superconductivity is an area of active research. To understand it, let us assume there is a thin smooth ring of radius A in horizontal plane. The ring is fixed. On the ring we have threaded a small bead of mass m and charge q. Suddenly an external magnetic field is switched on. The field is cylindrically symmetrical and quickly achieves its maximum value B0. In addition, assume Bohr's quantization is valid. Then you need to calculate what is the magnetic field. So as there is time varying magnetic field, it will be creating induced electric field which will be accelerating the charge. So force on the charge is given by Q into E, which will be creating the acceleration. Now if you integrate this, you will be getting what is the velocity. If you want to integrate this, you need to understand how did E come into picture. When you write E bar dot dl bar for a closed loop is rate of change of flux. Now initial magnetic field is B0, final magnetic field is almost zero, because they said neglect the magnetic field because of the charge moving. So in that case, integration will turn out to be A by 2 times of B0 magnitude wise. From there you got the velocity. Then if you apply angular momentum conservation, quantization, whatever. So mvr equals 10h by 2 pi. You know mv value. When you substitute, you will be getting the needed answer. A parallel beam of monochromatic light of wavelength lambda, that is in air, and they don't say the meaning is it is in air, is incident on the slits separated by distance 2 mm. There is a screen at a distance 1 meter which is large. If the refractive index of the medium between slit and the screen is varying with time, this one is varying with time, and till it becomes 1. So a glass slab of mu equals to 5 and thickness 0.2 mm is placed in front of one of the slits as shown in the figure. In figure, y represents the position of central maxima. Then you need to calculate what is that y value and what is the speed of that, and fringe width at that particular time. So first of all, let us take a general situation and let us see what is the optical path difference there. Now we will be converting everything into vacuum. If I take this length is L1, this length is L2, mathematical length. I am bothered about how much is this, let me call it as tau as the thickness. So out of L1, tau I am removing. So L1 minus tau is in this medium whose refractive index is mu. So its optical path length is going to become mu times of L1 minus tau. And this thickness T is of refractive index 5, so its optical path length is going to become 5 tau. So basically I converted everything into vacuum. If I want to create the same phase difference there, this much length is needed in vacuum. Similarly, L2, how much length is needed in vacuum to create the phase difference, same phase difference as this mu into L2. Then I need to see what is the optical path difference, this minus this. So that is going to be path difference. Now if that is equals to 0, it is going to be central maxima according to the definition what they were taking. Now L2 minus L1 geometrically we know, L2 minus L1 mathematically we have already concluded, which will be equals to d sin theta. For small angles it is going to be d tan theta, which is dy by d. Then substituting the given values, mu is the only one which varies with the time, so y will turn out to be this much. Now according to the given question, When you substitute t equals to 0, mu value is 20. So when you substitute mu equals to 20, you are getting minus 0.075. Anyway, we are not interested in up or down, we just interested in magnitude. So that is going to give you option 2 for P. Then similarly at t equals to 5 seconds. At t equals to 5 seconds, it may look like mu is 0, but they said after becoming 1, it doesn't change. So you have to substitute mu value is 1, then you will be getting 0.4. Then they were asking what is the speed of the central maxima, that is at what rate this is changing when it is at the geometrical center. Now when it will be at the geometrical center, that you should be able to understand easily when all the mu values were same. That is when 20 minus 40 is 5, that is at 3.75 seconds. So I will be differentiating this, then mu value is 1. Sorry, mu value will become 5, right? Mu value will become 5, and d mu by dt according to the given question, it was magnitude wise 4. That will give you option 4. Now similarly, now fringe width they were asking. See, when they ask fringe width, then I need to understand from liquid point of view. Now when that wavelength is going into liquid, its wavelength is going to change. Till now I converted everything into vacuum, but when they ask about fringe width, I should be converting everything into liquid. So lambda d by d, but lambda in what liquid is going to be lambda in vacuum by mu. A Brewster window is used to minimize losses by reflection. So it is making reflection less. A typical example is a helium neon laser with sealed glass tube as shown, where glass windows separate the laser gas mixture from the ambient air. The light coming from the laser is polarized laser, and reflection has to be minimum. This light emanating from glass tube strikes two glass plates at each one of the ends. If the conditions are appropriate, there is no partial reflection from the glass plates. The light is focused using convex lens as shown. The refractive index of the glass can be assumed to be 1.5, and that of both the sides of the glass can be assumed to be 1. Now anyway, they said Brewster and all, so you should be understanding it has something to do with Brewster's angle and reflection. So basically it is something like this. If you already, or it has something to do with this. When you send the light at Brewster's angle, the reflected ray will be having only one component of electric field. So if this component of electric field was missing in the incident one, there won't be any reflected one. So if a polarized light is sent at Brewster's angle, there won't be reflected ray. If polarized light is sent at Brewster's angle, tan beta equals to mu. But they were asking this angle, that angle also you can calculate. So Brewster's angle, so that gives you option A correct, option B also correct, and incident beam should be plane polarized with the plane of electric field same as the plane of the paper, so that also you should be understanding. From here, if this electric field is polarized only in this direction, then this will be there, this won't be there. So that electric field is polarized in the plane of the paper. So option C is also correct. Option C is correct implies option D is wrong. Then it was once suggested that the mirror for an astronomical telescope could be produced by rotating a flat disk of mercury at a prescribed angular velocity. The equation of the free surface, that is liquid fluids question, so you will be taking some element like this at a distance z, its pressure will be P naught plus rho g z, then you will be taking this thing and you will be making net force towards the center equals to m omega square r. So when you take this element and when you write net force towards the center equals to m omega square r, you will be getting pressure here into area, or P naught into A will be getting cancelled. Mass of that element into acceleration of center of mass. From there you will be getting, it is a parabolic curve. In 3D it is going to be paraboloid, and it's like y square equals to 4a x form or whatever. So in that case this is going to be 4 times of focal length. From here focal length, yeah, so depending on omega, focal length will be changing. They were asking if you want to produce focal length of 0.1 meters, which is 10 centimeter, what should be the omega? And understand? Okay, so I didn't show you exactly. Focus and focal length will be same, and mathematical focus is same as physics and all, but I think it was somewhere. Probably I will attach some PDF along with this. I think there were a couple of videos in the doubt clearance where parabolic mirror, like no matter whether it is paraxial rays or non-paraxial, if you send them parallelly to the principal axis, they will meet at the focus. Medium is separated from other medium of refractive index mu naught by xz plane. Refractive index of the medium varies with y coordinate. So then you need to mark the options. So if you look at what I am trying to do, I am trying to find what is the minimum mu value. So for that I am differentiating it and making equals to 0, and I can see like second differentiation is positive. The meaning is it is going to be minimum there. When you substitute the value back, you will be getting minimum value is this much. So when you keep going at certain location, which was mu1 by 2 mu2, it is going to be minimum, and it is going to be this much, this much. So, and you know, these are like slabs, so you can apply mu sin theta equals to mu sin theta at any location. So now I am interested only in the least mu part, because if I apply mu sin theta here to equals to here, if that turns out to be, the refracting angle turns out to be greater than 90, the meaning is it can't cross that layer, it has to totally internally reflect. And suppose this mu sin theta gives me some angle of refraction there, it is going to go. So once it crosses the rarer medium, rarest of the all, then like there is no chance of total internal reflection anywhere. So I am interested in what is the minimum mu value, because if their total internal reflection happens, if I know that total internal reflection should happen there, either it can happen somewhere or there for sure, and it has to come back. It has to come back. If total internal reflection should happen, then this mu sin theta should be greater than or equals to greater than this mu sin 90. That mu was mu minimum, which we were interested in, right? So ray will definitely return, that we can't say, that depends on mu naught, that depends on the values. Ray will never return into the medium, that we understood it. Sometimes it can return, sometimes it won't return. So under this condition it will be returning. If this condition is not satisfied, it will go. If the ray causes particular y, that is this particular y, there it is refractive index is minima. If you know for sure it is going to refract there, the meaning is it has refracted at all the places, it was never total internally reflected. For ray to not return to the medium, so it is the opposite of this. So for under this condition, total internal reflection will happen. Under the other condition, the ray will be not coming back. If A is the angle of the prism having refractive index mu, there were a couple of options, and most of them you would have learnt in the class. I mean, I didn't write it in a explanatory way, but that should roughly give you the idea. Light will not emerge out of the prism. The meaning is R2. See, first of all, I1, R1, R2, I2. That's the sequence I will be taking. In first angle is I1, refracted angle is R1. Next angle is R2, and the other is going to be I2. So light will not emerge out of the prism. If light is not emerging out of the prism, R2 should be at least critical angle or greater than critical angle. So yeah, this should be at least critical angle or greater than critical angle. Now, if I am bothered about what is this value, now R1 plus R2 is a constant, and R1 maximum, if you are inquiring about R1 maximum, R1 depends on I1. If R1 maximum, that implies I1 is maximum. I1 maximum is 90. For 90 degrees, R1 maximum is going to be critical angle value wise. So this maximum value is C, and this maximum value can be anything, but its minimum value should be at least C for not for total internally reflecting. So when you do that, you will understand the minimum value of A should be at least 2C. at least 2C, then there won't be total internal reflection. So option A is correct. Similarly, going with option B, again R1 plus R2 is A. The ray emerges out. So they were saying ray emerges out. The meaning is R2 is never becoming critical angle or greater than critical angle. So this maximum value is C. The meaning is this minimum value is A minus C. And you know Snell's law at the initial location, and you understood R1 should be greater than A minus C. When you substitute it back, you will get option B is wrong because of the symbol. That should make sense also. When ray emerge out, deviation will be minimum. See, deviation it will be minimum when I1 equals to I2, R1 equals to R2. There will be mathematical proof also, but we will be taking for granted anyway. So if you apply Snell's law at any location, 1 sin I equals to mu sin R, where R is A by 2. And maximum deviation is going to happen at 90 degrees. We mostly take it for granted from the graph. Below this, total internal reflection and stuff can happen. So maximum deviation is going to happen at 90 degrees. And yeah, I think this is already there somewhere, mathematical way of proving like minimum deviation will happen when I equals to I1 equals to I2. A clean surface of metal in vacuum tube is irradiated with monochromatic light of 500. Okay, so there was some stuff given, and it's straightforward question. So if you are sending this much wavelength, this much will be the energy you are sending. Out of that, some will go as work function, rest will come as maximum kinetic energy. From there you will be getting work function. So maximum kinetic energy is 0. Now how did we decide maximum kinetic energy? Because they said stopping potential is 0.8. So from there you understood maximum kinetic energy is 0.8 electron volt. Similarly, once you know this work function, you will be using it in the second case to get lambda value. Once you get lambda value, you can get the frequency value. It's only energy conservation, and based on work function, based on stopping potential, you can get what is the maximum kinetic energy. Particle of mass 4m of energy E, half into 4m into U square is E, strikes a free neutral hydrogen atom. Oh, I think hydrogen atom mass should have been given. Is it not needed? I think it has to be given. It has to be given as M. Oh. Okay, so maximum kinetic energy loss that can happen is in perfectly inelastic collision, which is half into mu into V relative square. So maximum energy loss that can happen is this much. But I am taking 1 by 5 out so that I can show you this is given as E. So maximum energy loss that can happen is E by 5. If that is greater than or equals to 10.2 only, there is inelastic collision possible. If it is less than 10.2, if the maximum loss that can happen is less than 10.2, hydrogen don't accept it. So for excitation to happen, E by 5 should be at least 10.2. That is, E value should be at least 51. So option A is wrong. For 60 it may happen, yeah. Like in some inelastic case where it can lose 51 units energy. It loses 10.2 units energy. Then see, if they give 60, the meaning is 60 by 5, 12. So it can lose 12, but even if it loses 10.2, that's sufficient enough for us. If the striking particle has more mass, if the striking particle has more mass, you would have got this value more number. So the energy utilized, the energy coming out for excitation is going to be less number. So you have to send it with more energy now. More the mass, you have to send with more energy, because more kinetic energy will be staying there itself, only less kinetic energy can be utilized. In YDSC apparatus, if we use white light, then the central fringe will be white. That should be understandable. Everything will be bright fringe there, all colors. And the fringe next to central bright fringe, this This depends on how our eye works. So our eye will be perceiving absence of blue as red, and it will be able to detect red and blue more, and maybe green. So in WebGR, if blue is missing, we will see it as more of red. So I mean, that's kind of how our eye perceives. And I don't know if it is there in syllabus these days, like this is from NCERT, where the same question will be there. The interference pattern, due to different components of colors of white overlap incoherently. The central bright fringes for different colors are at the same position. Now there is incoherent thing, so you can't really find dark and bright fringes because yellow and green are not coherent anyway. So out of all the colors which are perceivable by eye, sensible, much blue is going to be absent sooner. Wherever blue is going to get absent, we will feel it as red in color. So we already understood there will be incoherent thing, so we don't really bother about that. So they have given some scenario and they said image is somewhere, and from that you should find what is the focal length and what is the y. So they already said image is at 30 comma minus 1, 30 comma minus 1. Image is at 30 comma minus 1. Now you know when there are two lengths, so they will be converging more, or you can find the effective focal length. From there you will understand if each focal length is 60, then effective focal length is going to be only 30. Powers are going to add up. Single power, if it is converging at 60, two powers they will be converging at 30. Or you can use the equation. So anyway you will understand the image is forming here, so focal length of the lens is 60. Parallel rays will meet in the focal plane anyway. Right. Now if I remove this lens, because of these, the rays will be meeting here, which is at distance 60. Now if while these rays are going this way, if I put this lens back, while these rays are going to converge this way, if I put this lens back, now this is going to act as an object for this lens, where this is the principal axis. So instead of finding this guy's image, we will find this guy's image. For this lens, object is at a distance 60. These are thin, you should understand these are thin. Object is at a distance 60, image is at a distance 30. So magnification you can find will be 1:2 by similar triangles, or V by U. Right. So magnification is going to be V by U. This is V and this is U. So magnification is half. So if I take an imaginary arrow, its length is going to become half of this. But they said this value is 1. So the meaning is this equals to this plus this. X value is given in the question, and in fact you should understand how much distance you have moved this down. This distance is, this is y, this is x, so this is y minus x. So you have moved this one by y minus x down. So this length is y minus x. If this length is y minus x, because of the magnification you understood this should be y minus x by 2, and they have given this value is 1. So this plus this equals to this, right? So intensity at the central was given, and I by I naught value at a point on the screen, that is 3/4 wavelength farther from one edge than the other. So if you talk about single slit, so they were telling this is 3/4 lambda, A sin theta is 3/4 lambda. A sin theta is 3/4 lambda, then beta value is going to be 3 pi by 2, then intensity ratio will be sin beta by 2 by beta by 2 square. Beta value we calculated, you just need to substitute and get the value. So they were asking about some deviation maximum. So suppose a ray is coming with an angle of incidence psi, So it need not be this way, you can draw anything, but if you rotate it looks like this only. So angle of incidence is I, angle of refraction is R. If this angle is R, this angle is going to be R by triangle thing. These two lengths are equal, so these two angles will be equal. Angle of incidence equals to angle of reflection. Again by triangle thing, you can say these two angles are same. Now again by using Snell's law, you can say this angle should be I. Now you should understand here there is partial reflection as well as refraction. We are talking only refraction because they were saying so, they were interested only in that. Or during rainbow formation, it is happening because of some particular thing, so we are interested only in that, we are not interested in the reflected part. And in fact here there will be refracted ray and there will be reflected ray. It is not total internal reflection. You can see obviously when it is when it is coming at an angle R, it can go with at an angle I, so this is not total internal reflection. So anyway, what is the deviation here? The ray used to go like this, but it bent like this. This angle is I, this angle is R, so it has bent by I minus R. Similarly here, it used to go like this, it has bent by 180 minus 2R. Again here it has bent by I minus R. So totally how much it has bent? I minus R, pi minus 180 minus 2R and I minus R. So you will be getting this much. Now you need to see what is its maximum value. But there are two variables here, but you know they are related. They are related using Snell's law. So basically I can see R is a function of I. Then I want to see when it's its maximum. So its first differentiation should be 0. When you do that, you'll end up getting some expression, but yeah, you can solve it and you can get the required answer. The rectangular box shown in the place of lens. By looking at the ray diagram, answer the following. So they have sent one parallel to the principal axis, that is going this way. So when you extend it, it is meeting somewhere here, so that is going to be focus. And they asked in fact to calculate this value, y value. And they were sending some other ray also. So once you see the ray going from here, you can understand if the object is placed here, image would have formed here. So if the object is placed at focus, image would have formed at 5, that's what they were telling. Anyway, by this time you should have understood it is diverging lens. Right, so when the object is placed at focus, image is forming at 5. Image is forming at 5. So when you calculate it, you will be getting the magnitude value is, magnitude wise it is 10, and we already understood it should be negative sign. And I think most this formula we get from similar triangles, so if you can manage to look at similar triangles, probably you should get the answer that way also. A thin uniform radioactive coating of alpha emitter is applied to metallic sphere. Sphere is connected to ground by means of a thin wire of resistance R. Assume that the sphere is uncharged at t equals to 0. The initial activity of alpha emitter is A0 and disintegration constant is something given. Also assume that the alpha particles emitted go out of the sphere. Find the time at which charge on the sphere is maximum. Now, why is charge coming into picture? Because of the emission. Because of the emission, it is going to become negative charge. Because of the negative charge, this higher potential, this is lower potential, it is going to be, so current will start flowing. So at any moment, at any generalized moment t, let me say this was negatively charged and minus q, and the activity, the number of nuclei which are active were n0 into e power minus lambda t, that also you know. So activity is going to be a0 into e power minus lambda t. Now because of this, it is going to neutralize, or this value is going to increase, right? So the rate at which this is changing depends on this guy as well as this guy. Because of this it will increase, because of this it will decrease. Now activity gives me how many alpha particles are coming out, and charge on each alpha particle is 2 times of charge of the electron. Now how to find this current? This current is potential difference by resistance, and this value was given in the question, which I can manage to substitute as 2 lambda q. Now And they are asking what is Q maximum. For that, I should find Q as a function of time and I should differentiate it and make it equals to 0. So for that, we should solve this differential equation. I think you will be knowing that integration factor. So when you multiply this equation with e power 2 lambda t, that should make sense to you. 2 lambda is coming here. So if you put e power 2 lambda t, its differentiation is going to be this much. Then you can club them and you can integrate. At t equals to 0, Q value of 0. So the term substitution is going to be 0. T equals to 0, this is going to be 1. So be careful with that. From there you will be getting Q as a function of time, but we were talking about minus Q. Anyway, that doesn't really matter. First differentiation has to be 0. When you do that, you will be getting the required answer. I think the next question was also in the similar format. This is there initially, it is forming this. Because of this, it is going to get formed. So at any time, its value is going to be n naught into e power minus lambda 1 into t. Now the rate at which this is forming depends on this and disintegration depends on this. So the rate at which this is changing depends on its formation, which depends on this number. This is the rate at which this is disintegrating or this is forming. So this is the rate at which this is forming, and because of this there will be a disintegration, depends on its number itself. And we need to solve this differential equation again by the same way. If you understand, there is lambda 2 here. If you multiply with e power lambda 2t, you should understand this differentiation will turn out to be this much. Then you can club them and you can integrate it. The same idea, it's again the maximum, you can differentiate it and make it equals to 0. A small quantity of solution containing sodium radionuclide, half-life is 15 hours and activity is 1 microcurie, is injected into the blood. The sample of the blood of the volume 1 centimeter cube is taken out after 5 hours. And you are measuring the activity. Based on this, they were asking you to judge, understand how much is the volume of the blood in the person. So if I assume the volume is V and it is uniformly distributed, whatever you are injecting, its activity after some time is going to be this much. After some time, that is 5 hours. After 5 hours is going to be this much. It is in the total volume, but you are picking only 1 centimeter cube and you are saying in that activity is this number per second. So for the total volume, this is the activity. For this much volume, this is the activity. 1 centimeter cube, this is the activity. From there, you should be able to understand what is the total volume. A ray of light of intensity I is incident. It undergoes partial reflection and refraction. At each reflection, 20% is reflected and the rest is refracted. Find the ratio of maximum and minimum intensity. Out of this, 0.2 is getting reflected and 0.8 is transmitted or reflected. Out of this, 0.2 is getting reflected, the rest is transmitted. Out of this, 0.2 is reflected, rest is transmitted. And these two are going to interfere depending on the angles or depending on thickness. So the maximum is going to happen when the amplitude is going to become A1 plus A2 resultant of them, whatever, considering the phase change and all. Maximum amplitude is going to be A1 plus A2, minimum amplitude is going to be A1 minus A2, and intensity will be that square, A1 plus A2 square by A1 minus A2 square, and amplitude will be proportional to root of intensity, right? So we got the values, you can substitute it to get the answer. And I have attached a couple of questions from last exam where some of the people were asking to solve, or like they were trying to solve using torque. So I did by torque way, which is almost the same way. And so someone was telling me Thevenin's is much better option. So I did this question by Thevenin's. Right. So similarly, if I am finding something like this, if someone is suggesting me better ways, I'll be uploading in the next or something like that. So, right. Thank you.